All right, number 19. So a machine pours 250 milliliters of juice every 4 seconds. That's quick. Just let you know, guys, that is super quick. How many liters of juice does a machine pour every minute? Okay, so it looks to me we've got some kind of ratio and proportion question. So let's write these facts down, yeah? So you've got 250 milliliters, that takes 4 seconds. We want to figure out how many liters is poured in every minute. Well, before we get to liters and minutes, let's just convert them for a second, yeah? So a minute, we should already know at the stage that it's the same as 60 seconds. So essentially, we're trying to figure out how many milliliters are there in 60 seconds. And then we could change it to liters. Now, the trick I do is always find 1 second. Always find a single unit. Well, to get 1 second, the only way to go from 4 to 1 is to divide by 4. Meaning we need to divide this number by 4. So 250 by 4. So let's try it here. We can say, all right, 4 into 250. I'm going to scroll this up a bit. Well, how many 4s go into 2? None. So we say, okay, how many 4s are there in 25? How many 4s are in 25? Well, 6, remainder 1. So now we've got 10. So how many 4s are there in 10? Well, there's 2. And it should give us a remainder of 2. But because there's no more spaces, add an extra decimal 0 and put the 2 here. And therefore, we ask ourselves now, how many 4s are there in 20? Well, this divides perfectly and gives you 5. So actually, every second, this machine pours out 62.5 milliliters of juice. So that number I don't quite like. Now here we want to find every minute. And to go from 1 to 60 seconds, we need to multiply this result by 60. So let me just put 62.5 milliliters. And now we're trying to find 60 seconds. Okay, so to do this one, we're going to times this result by 60. So 62.5. And the trick is you could just times it by 6 and then add a 0 later. Times 6. So let's do this. This will be nice and easy now. So 5 times 6 is 30. So 0 carry the 3. 6 times 2 is 12. Plus 3 is a 15. So 5 carry 1. 6 times 6 is 36. Plus 1, 37. And just put the decimal place where it belongs, which is one place after, so here. And since we times it by 6, well, we want actually 60. So times in this result by 10, you're going to get exactly, well, move decimal here, 3,750 milliliters. And we should know that in a liter, there are 1,000 milliliters. So in other words, if you've got 3,000 something milliliters, you're going to have 3.750 liters, or just 7.5. You don't need to write a 0, but you can if you want. So take the fractions that are equal to 20%. Ooh, all right, this is an interesting one. So let's ignore the examples here for a second, yeah? My trick is to firstly figure out what 20% actually is, if you're not too sure. Well, when you want to change a percent to a fraction, the clear way is to know that percent means per 100. So this means 20 per 100, or 20 out of 100. Now all you got to do is simply realize that we can just cancel down this fraction. Well, they both got 0, so let's divide both by 10. So the zeros go, left with 2 out of 10. And then breaking this down further by dividing 2, you can get 1 out of 5. So 20% is 1/5. So looking at all the values here, well, this is one of them. Now, is anything else similar to 1/5 or 20%? Let's have a look. So you got 1 over 20, that does not even look close, so that's false. 20 out of 40, well, cancelling down the 0, you got 2/4. Cancelling down, you get a half. Definitely false. 3/15, let's have a look. Dividing both by 3, cancel by 3, you're going to get 1/5. So yes, that's another one. And 2 out of 100, well, that doesn't even look close. Off. So the only two answers are those two. All right, number 21. So this question is arguably one of the trickiest questions that they've ever made in any SATS. And here's why. And let's have a look. So Adam has this rectangular piece of card and it is marked with grid lines. All right, cool. Now Adam decides to make 2 straight cuts along the grid lines. All right. The 2 cuts divide the rectangle into 3 shapes. So here they want us to produce 2 squares of different size and a rectangle. Now use the grid lines. Okay, using the grid lines, draw 2 lines that show where Adam could have made his cuts. Use a ruler. All right, so this is where things get funny. Now my advice for these kind of questions, yeah, when they give you something of fixed dimensions like a square, always focus on the square, not the rectangle, because a rectangle could be practically any shape that isn't a square, and you have so many possibilities of rectangles. But for squares, you only have only so much because they need to be same dimensions. So what I would do is firstly maximize the possibility. Try and make the biggest square you can, and that is a 5 by 5 square. So something like, let's say here, so 5 by 5, so like this. So this is a possible square. Now let's do that. So this is square 1, yeah. Now second square, yeah, so you only got practically one or two options. You can make a 2 by 2 square here, and that's it, and this is square 2. And now they want us to make a rectangle. Well, that's easy. That's just what we have left. So this shape here would be the rectangle because it has different dimensions to a square. And that's it, guys. We're literally done. All right, 22. So the graph shows the maximum temperature for 5 different days. So you got Monday, Tuesday, Wednesday, Thursday, and Friday, and your temperature in Celsius degrees. And here are your 5 temperatures. So it looks to me Friday was the warmest and Monday was the coldest. Now, for the first part, for what fraction of the 5 days was the maximum temperature below 10 degrees Celsius? So in other words, how many were below 10 degrees out of 5 days? Well, we can see that only 2 below are the one from Monday and one from Tuesday because they're both less than 10. Meaning the fraction would be 2 days out of 5. And yeah, that's it. That's 1 mark for that. Now, what was the mean maximum temperature to 1 decimal place? Okay, so they use the keyword mean. Now, to find the mean, all you got to do is just add up all of these 5 numbers and then divide it by how many numbers there were. In this case, 5. So let's do it. So I'm going to do a little column then, yeah? So put out from biggest to smallest. You got 12.4 plus 11.8. Okay, 11.9 there. Plus 9.3 and 8.1. So it doesn't really make a difference, but it's good to do in order. Personally, this 2 should be the other way around. So adding these numbers carefully, we should get the following. So you got 4 plus 8 is 12, and you can say 9 plus 1 is 10, which add to 12 makes 22, add 3 is 25. So do in any order you want, guys, yeah? 5 carry the 2, and let's do this one. 2 plus 2 is 4, add 1 is 5, 6, and a 6 plus 9 is 15. 15 add 8 is 23. So 3, carry the 2. And again, last set of numbers. 2 plus 1 is 3, 4, 5. So it's 53.5 in total. Now the mean wants us to divide that by 5. So on the side, you got 5 into 53.5. So I can already see it's going to give you a nice answer because the last number is 5. So 5 into 5 is 1. 5 into 3 you can't do, so 0 carry the 3. 5 into 35 is just 7. So that's it. So the mean temperature was 10.7 degrees Celsius across 5 days. If you got this all right, you're going to get 3 marks in total. And here we go, guys, the final question of the paper. So if you guys have reached this far, once again, give yourself a pat on the back because you guys did amazing, yeah? So let's finish this off and see what Amin and Stefan have done. Well, Amina made this cuboid using centimeter cubes. All right, so here's our cuboid with dimensions 4 by 6 by 3. Now, Stefan decides to make a cuboid which is 5 centimeters longer, taller, and even wider. So it's way bigger cuboid. What is the difference between the number of cubes in Amina's and Stefan's cuboids? Okay, so to work out the number of cubes, they're literally trying to say calculate the volume and then subtract them for both of them. So we can say, all right, let's look at the volume for Amina's cubes, yeah? We're going to call volume of Amina, VA. This is basically 4 times 6 times 3. And, well, working that out, that's not too bad. I always do the 2 biggest numbers first. So 4 times 6 is 24. And then times that by 3, well, you can do this fast. 2 times 3 is 6, which is 60. Plus 4 times 3, which is 12. Add them up, you get 72. So that's the size of Amina's cubes. Now for the volume of Stefan's cubes, so VS, he said that each side is 5 centimeters longer, taller, and wider, meaning 4 add 5 to it makes 9, by add 5 to 6 gives us 11, and add 5 to 3 gives us 8. So that's, okay, that's a much bigger number. So let's work this out. So you got 9 times 11 is 99 times 8. Oh man, that's a big number. So let's work out using another way, yeah? So 99 times 8. Oh, this is easy. They're both 72, isn't it? So 9 times 8 is 72. So 2 carry the 7. This is 72 again. Add 7. gives us 79. All right, looks good. It looks decent. So, okay, well, that's way bigger, man, that volume. So therefore, we want to work out the difference between two of these values, between 72 and 792. So it's going to be now, let me change the color, pen, 792 minus 72. So subtracting, okay, this is easy. 2 take away 2 is nothing, 9 take away 7 is 2, 7 take away nothing is 7. And that's it. So I guess the difference is 720. Okay, guys, fun fact. So just look at these numbers. You can see all of these are divisible by 9. Why? Because you've got 7 plus 2 is 9, divisible by 9. 7 plus 2 is 9, plus 9 is 18. Add up the 1 and 8, that also makes 9. And 7 plus 2 plus 0 is also 9. So yeah. But anyway, guys, thank you for watching. I hope this video helped. And if you guys enjoyed the video, give me a like, share, subscribe with your friends.